We will apply what we call the net change theorem whenever we are integrating a rate of change. If we integrate a rate of change of a function over a given interval, this produces the change in that value of f. Over here on the left is a visual. Here we're integrating the rate of change of f. Remember, that rate of change is just the derivative. If we integrate that derivative, ultimately what we'll find is the difference between this f value and this f value. And this is the change in f over that given interval. Now that's really abstract. So let's get into a real life application of rate and change. We're back to Rochelle and her stationary bike. The number of rotations per minute of the wheel of the stationary bike are modeled by this differentiable function, r, between 0 and 9 minutes. Selected values of r are shown in the table above. They want us to use a Left-Riemann sum with 4 subintervals to approximate this definite integral, and then explain the meaning of what we found in context of the problem. So I think the first part we should be able to do with no problem, right? A Left-Riemann sum. So our change in time is going to be different for every rectangle. Here it's 3 and my left height is 72. Here it's 2, my left height is 95. Here it's 1, my left height is 112. And here it's 3 and my left height is 77. So that definite integral from 0 to 9 of r of t dt is approximately 3 times 72 plus 2 times 95 plus 1 times 112 plus 3 times 77. And remember, you do not have to simplify this unless you're going to use it for a future part of a problem. So now, what does that mean in context of the problem? So let's think about this. R of t is in rotations per minute. So when you do this definite integral, you're taking rotations per minute for the height of each rectangle, and then you're multiplying by the base, delta t, which is a change in minutes. So if you're taking rotations per minute and multiplying by minutes, those minutes are going to cancel out and just leave rotations. So we can say this represents the total rotations of the wheel from t equals 0 to t equals 9 minutes, right? Because if we take rotations per minute and multiply by minutes, we're just left with the total rotations over that time.